GCSE Maths Paper 2 Higher Tier of June 2023 series. Let's get going. Okay. Can you type in a calculator? It is, once again, our favourite question of the paper. Hopefully you do know how to use your calculator, otherwise this is going to be a painful paper for you. Make sure you type it in right, both in and off the calculator, because these are the easiest marks you can get. You know everyone else will get them, so don't lose them. There you go. What's the reciprocal? 1 over it. Type that into your calculator. What do you get? 8 over 5. How lovely. Let's go. Right, 60 is a product of its prime factors. Okay, well 60, that's 12 and 5, because we know our times tables. 5's prime, 12 isn't. 12 is 2 and 6, which is 3 and 2. And then those are our primes. That's 5 times 3 times 2 squared. There are 48 counters in a bag. There are only red and blue counters. This is the thing. How many are the thing? Well, clearly she does not know how to do ratios because, well, these are sets, essentially. You say, well, okay, the bag comes in sets of these, so you have to add up the ratio, essentially. And then divide through, so it's 48 over 3 gives me 16 is each part, essentially. So there's 16 red. Try and explain the ratios wrong and then say the real answer. It's only 1 mark, so don't stress it too much. N is an integer. What's the greatest possible value of n? Well, it can't be 5 because they've given us a strict inequality, which means the greatest possible value of n is 4. Show this inequality. We're going to colour in this because it can be -4. So it's like, you imagine the circle as a zoomed in point, if you will, okay? So it's zoomed in, and they say, okay, was there a line here or isn't? And there is one at -4, so we colour it. There isn't one at 1, so we don't colour it, though we might want to not have line inside that. So it would look like that, okay? Solve this. Okay, well, first we'll add 4 to both sides. So we get 2 over 5g. It's bigger than, it's less than 10. So 2g is less than 50. G is less than 25. Now double check that. Does that sound about right? Yeah, it does. Moving on. And also g is positive here, and we didn't do anything with g, so we don't need to worry about that either. Okay, moving on. Here's a triangle and a rectangle. Area of triangle is 10 centimetres greater. Okay, so the area of each. Area of triangle. So that's 8 times 6x times a half, which is what? 24x. And rec is 4x minus 1. Is that 5? Yeah, it's 5. Which is 20x minus 5. And we know that the area of the triangle is 10 centimetres greater. So that's 24x. Was 10 bigger, so we have to put it on the other side. Make sure you put it on the right side. It's an easy way to get it wrong. So I've added 10. That's why that's plus 5 instead of minus 5. Which we then cancel that. So now we've just got 4x equals 5. X equals 5 over 4. Yes, moving on. Yeah, this is a boring question, but we have to do it, okay. So, how much was waste in paper, or was paper and glass? 800 times 0.57. We then say, okay, well, this comes in parts of 19, so we're going to divide this by 19, and we're then going to times it by 7, and then we'll get how much glass they have. So we pick up our calculator, which, where have I put it? Sorry, found it. I really shouldn't have put it down. I am doing a calculator paper here. So times that in, divide it by 19, times it by 7. So we get 168 kilograms. Moving on. You should be able to go backwards as well, which is a good way to check your answers right if you're lots of time in the exam, you know? Okay. D is rounded to 1 decimal place. Okay, so it can be 12.65 to 12.75. Yeah? And again, the inequality signs support that. If you want to type it in nicer than I will, but, you know, it's fine. Times and buys a home, it increases by 4% each year. This and things, and... Okay, so let's think. So we have T and we have R. So we have 15,000 times 0.04. Sorry, I've said that wrong. 16,000. We want to type this in so it's easy for them to give us marks. You always want to make it easy for an examiner to give you marks. If they have to sift through all your working, they're going to be most displeased, and your grade might suffer because of that. I'm not saying it should, but there is a good chance it might, so be careful. And that was 16,4,836. Have a look at these two numbers, which is bigger? This one, Rachel. So moving on. Okay, well, unfortunately, I have to kind of go to and from, which is annoying, but we can do it. So I'll write down the information we need. 20,48,64. And I assume it's, yeah. So that's by the end of 30, by the end of 40, by the end of 50. Sorry, this is just because you have it all lovely in your thing. I don't, so we're going to have to do it like this. 75 and 80. And it remains the same pattern. So that's at 60 and 70. So at the end of 30, it needs to be at 20. At the end of 40, it needs to be at 48. 64 at 50. 75 at... Sorry, I've hit that wrong. 75 at 60. And 80 at 70. So I'm just going to rub out that point there so we don't get confused. And then I'm going to connect up the dots, essentially. Ooh, how lovely is that? Okay, did they want me to do anything else? Yeah, they did. What's the median age? Okay, so we read across at 40 because that's what the thing is, which then gives me an average age of 36. You'll probably get a better estimate than me because I didn't try very hard during my cumulative frequency graph. You guys should try much harder than I do, okay? Work out the estimate for the probability that the dice will land on 6 both times. Okay. So a dice is thrown 60 times. It lands on 6 15 times. So odds of a 6 is 15 over 60, which is 1 over 4. So you have to throw 6 both times. That's 1 over 4 squared is 1 in 16. What can I say about the value of n? She wants a more reliable estimate for probability than part A. She should throw it more than 60 times if she wants it to be more reliable. Use algebra. Okay, that's boring. Do any of these numbers go in nicely? Not really. So I'm going to times this one by 3 and that one by 2, because then the x's will be the same, which will give me 6x plus 18y equals 15. And 6x minus 8y equals minus 24. And now I'm going to minus this one, like that, and I'm just going to add these together, which gives me 26y equals 39, yes, which then gives me y equals what? 3 over 2. Nice value for y, so I'm more confident in my answers now. And then shove this back in. 3x minus 4 lots of 3 over 2 equals minus 12. So that's 3x, minus 6 equals minus 12. 3x equals minus 6. X equals minus 2. Moving on. 8, 10. Okay, so the first thing I see here is this line here is the diameter of the circle, yes? We know a few ways because this is a rectangle, so this must be the diameter, but doesn't really matter. The point is AC squared is equal to 8 squared plus 10 squared. So AC equals square root of that, which will give me, make sure you type it in right again, 2 root 41. So radius, hang on, no, don't even need to work out the radius. So the circumference is pi d, 2 pi r if you will, and this is equal to d, so we just times this by pi, which then gives me 40.23 to whatever, 3SF, so that is 40.2. Moving on. ABC is a triangle. Calculate the size of angle BAC. This one here, well, this isn't a right angled triangle, so unless we want to do a lot of drawing and a lot of using our brains, we don't need any, well, like, we don't need to do some weird things, but what we do want to use here is the sine rule, okay? Because we know the sine of 70 over 18, because remember you've got opposite sides, is going to be equal to the sine of the angle we're looking for. Actually, no, we're not going to do that. So sine BCA over 15. And look, I know what you're saying. Well, why are you calculating this angle? We need this one. Well, they haven't given me this side, but angles in a triangle do add up to 180. So once I get this one, we're still pretty good, okay? So let's work out what's the angle. So we go inverse sine. If you write down what you put into your calculator, you're less likely to get it wrong, and you're making the examiner's life easy, okay? Once again, make sure your calculator is in degrees. Everyone, if you go in to do a lot of maths, everyone has done this mistake. It's the most painful mistake you can ever make. I know people who lost out on places at university over it. So please be really careful. It's the most painful way to lose marks if you're not in the right mode. So then I take 180 minus this 51.5 minus the 70 to get my final answer, which is 58.4568 whatever. To one decimal place, that's just 58.5. Moving on. Show that this can be written in this form. Well, we're hopefully going to cancel something out here, aren't we? So let's factorise the top and bottom and see what happens. This is just going to be 2, 3, isn't it? So x minus 3, x plus 2. The bottom's a bit more painful because there's something in the numerator. I never like doing it when there's something in the numerator, so I'm going to quadratic formula that. Whereas the top bit, you can find something that adds to that and times this to that quite quickly, so I didn't need to. So let's think, right, x equals minus b, so that's 5, plus or minus the square root of b squared, which is 25, minus 4ac, which in this case is plus 24, all over 2a, a is 2, so that's 4, which then gives me 5 plus or minus, 7 over 4, which gives me 3, yes, and it gives me minus a half, which then means, take a 2 out, we'll have our x minus 3 term, which is in common, which is fantastic, and then we'll have our x plus a half term. We cancel those out, we get x plus 2 over 2x plus 1. And yeah, then we're done. Easy. Moving on. It's the form they want. Here's a quadratic sequence. Find an expression for n. Okay, well, let's find the first difference. It's 6, 8, 10, which means it's 2 each time. And then we half this, so we're going to start with an n squared. So then let's write out n squared. What do we get? 1, 4, 9. We then get 2, 6, 8. Do we? No, we don't. We get 2, 5, 8. Which is just an extra 3 each time, isn't it? Yeah, 11. So it's just an extra 3 each time, so that's just n squared plus 3n. Moving on. Here's a histogram. Complete the histogram. Okay, so between 30 to 40 hours, that's 28. So we can use this to find out what our scale is on the frequency density, and then we use this bit to complete this bit, yes? So 30 to 40, so this is 2.8, which means this whole thing means 1, so it's a nice scale. We then have this bit is 2.4. So then we go 2.4 divided by, 24 divided by 20 gives me 1.2, and 1.2 would be here. You should use a ruler. I am not, because I'm an adult not sitting this exam and it's a pain on an iPad. But you are, so go do that. No student used their phone for more than 60 hours. Work out total number of students. Well, we've got 20 and 24. We don't need to recalculate that. We've got a 20 here with 1.6, plus 20 lots of 1.6. And this bit is 10 with a height of 3.6, which will give me 36. Add all that together, what do I get? 28 plus 24 plus 20 lots of 1.6 plus 36 is 120 students. Moving on. Show this equation can be written in this form. Okay, so let's put x to the 4 by itself, and we get 5 plus x squared. There's a fourth root, so there's a good chance we want the x to the 4 by itself. X is then equal to the fourth root of 5 plus x squared. We then need an iterative formula. We're using it 3 times, so don't just spam it in your calculator, because then you'll get it wrong, okay? So I start by typing 1.5 into my calculator, and then I can use the answer button, so I think that just saves a bit of time. So if you don't do that, might be a good time to start, okay? So it can be a bit of a pain to type into your calculator, which is why I'm just talking like this. I'm still here, don't you worry, for the many of you who are worried. So I press it once, I press it twice, I press it 3 times. Which gives me 1.669763. That's all I've got to do, moving on. That's probably enough digits, isn't it? 2a to 5c is this. Okay. 2b to 7c is that. Okay. So, how do I want to do this? Well, that means I can kind of take A to be 3, and I can take C to be 5, essentially. That would give me the right spacing, wouldn't it? And then again, I can take B to be 5, or I can take the ratio of A to C. That's probably the easiest way to put that. A to C is simply 3 to 5. And the ratio of B to C is simply 5 to 3. Yes? So now, what do we really want here? What did they say they wanted? So this means, if I want to put this in the same terms, we need to times both of them by 5 over 3. Yes? So, when B is 25 over 3, C is what? 5. Yeah? There's a lot of ways to do this. I'm not quite sure which way is probably the best. So we've got this 25 to the 5 here, so that's the ratio of B to C. What we really want is, of course, A plus B to B plus C. I've got these all in the same sort of units now, so it's 3 to 5 to 25 over 3, lovely value, which then means 3 to 25 over 3 is then proportional to 5 plus 25 over 3. Let's times everything up by 3, because I don't really like this mess we've got going on here, which gives us 9 plus 25, and then 5 plus 25, which, yeah, that's definitely not right at all, is it? That's 15, there we go, that's what my mistake is, which gives me 40 to 34, which gives me 17 to 20 as required. Moving on. ABC is a right angled triangle. Calculate the lower bound for this angle marked x. Okay, how do we work out x? SOHCAHTOA, opposite over hypotenuse, we are using sine here. So sine of x will equal opposite over hypotenuse, 9.3 over 12.6. And we know that, well, in the range we're looking at, remember the graph of sine looks something like that, but in the range we're looking at, sine just looks like that. So sine goes up as the thing. So we want this to be as small as we can make it for the smallest possible x. So we want the smallest numerator and the highest denominator. So the lower bound is therefore going to be to the nearest millimeter, is therefore going to be sine of x is then equal to 9.23, or 25, sorry, over 12.65. And then we want to inverse this, so x equals the inverse of that sign. You can always imagine you're applying sine to the minus 1 to both sides, so sine to the minus 1 and then sine would cancel, so you just get x out. That's probably the easiest way to consider it, and I wasn't taught that for a very long time. Made my understanding of inverse functions so much better. Type that in, and I get x equals 46.98. Did they say what they wanted? They just said lower bound 989, so I'm just going to call that 46.99. Moving on. ORT as a triangle. Express MT in terms of A and B. Okay, M is the point on OR such that this. Just so you don't forget. So let's work out what OR is. OR is going to be A minus B. Make sure you get the arrows the right way. Which means OM is 2/5 of A minus B. So that's O to M. We want M to O, so we minus this. So MO equals minus 2/5 A minus B. And then we want plus OT, which is just A. So MT equals minus 2/5 A minus B plus A, which then gives me, what does it give me? 3/5 A plus 2/5 B. Okay. Here's a graph of y is f of x. Draw y of f of x minus 4. Okay, well that just means we take it down 4. So it's here. I'm not going to show it on here. I'm going to show it on here because it's a lot of effort otherwise. It'll look like that. Plot your points, plot them carefully, and then draw it, okay? That's all you have to do. Draw y of f of minus x. Remember, this just flips it in the y-axis, so if we take it here, we then would have it like this, okay? Because we flipped it in the y-axis, okay? Next question. Let's wipe out my thing when I was trying to scroll earlier. Are there any blue and red pens in the box? Number of blue pens is 4 times the number of red pens. So B is essentially 4R. That's an equal sign, not something else. This lady is taking pens out of the box and putting them back in. Okay. So what's the probability she gets at least one blue pen and at least one red pen? Okay, well, it's 1 minus the probability she only gets blues or only gets reds, isn't it? So what's the P of all red? Would be equal to, well, let's just think about it here. There's 4 times as many blues as red. So the total number of boxes, the total number of pens is R plus 4R equals 5R. So red is R over 5R. That's 1 over 5. So that's P of R all the times is 1 over 5 to the n. Similarly, blue is 4 over 5 to the n. So it's 1 minus 1 over 5 to the n minus 4 over 5 to the n. If you ever get confused on a probability question, see if you can split it into different situations like this and just take them off 1. Because remember, all the options have to add up to 1. So if you're interested in all but a few of them, if you just take those off, you get your answer. Right, so here are 3 triangles. We want to show this ratio. Okay, so area of ABG. You follow the lines along, so A to B to G. So yeah, it's this triangle. To C to D, to B to C, to F to G. So it's that quadrilateral, then C to E, like that. Okay, so it's the triangle and the two quadrilaterals. So we're going to start by considering the areas of the triangle. And I know you're thinking, well, hang on, they've asked us for the quadrilaterals. But you've got to remember the quadrilateral is just one triangle minus another triangle, yes? If I take the big triangle and I minus off the small triangle, I get the quadrilateral, which is what we're going to be relying on here. So, here's how we're going to do it. This is A to B to B to C to C to D. So let's write it in terms of A to B to A to C to A to D, which is going to be 1 to 3 to 6, which means triangle ratios of areas. We've got to square this because area is the length squared, is 1 to 9 to 36. Yes? Now, here's the thing, we have to take one off the other, which means this one is then 1 to 9 minus 1, because that's then the area of the quadrilateral rather than the thing. And then this one is now 36 minus the 9. No, 36 minus the 8. No, it is minus the 9, sorry. Make sure you know what you're doing. So that's 1 to 8 to 27, as required. Right, final question. What do we know here? Okay. I'm going to draw this into a straight line. So it's a triangle with... Sorry, it's a square with 4 little triangles. Find an area for the shaded shape. Well, this is A, this is A, this is A. This is a right angle because angle in each octagon will be, how do we do that? We take the amount of sides in our shape, we minus 2 for it, so that's 8 minus 2, lots of 180. We now want one side, so we then have to times that by an eighth, really, yes? Which gives us 6 over 8 times 180 equals 135. There are 2 lots of 135. You just want to double check that so the examiner knows you're not taking it for granted, which means that's 90, okay? We can now use Pythagoras on this, so we get a squared plus a squared is 2a squared, so we square root that to get root 2a. And this is just also a, so my lengths of sides, so my big square area is therefore equal to a squared, because I'm just going to take that out, 2 plus root 2 squared, yes? Do you see why? And small triangles, well, there's 4 lots of them, so we're going to start that with 4, and then it's half, that's a squared, so that's 2a squared. This comes out to, what does that come out to? A squared, lots of 4, plus 4 root 2. Is it 4 root 2? Plus 2. Yes? Well, I think it is. Type that into my calculator because I don't trust myself right now. Yeah, it's 6 plus 4 root 2. We then add on that to get a squared, lots of 8 plus 4 root 2. And now we want it in this form. And yeah, you might think, oh, hang on, we need to get it into the 2 root 2 form, so what do we do? Well, if I take out 4, what do I have? 4a squared. It's 2 plus root 2, which actually, no, in the form they want it's 4 lots of 2 plus 2 root 2, lots of a squared, so 4 equals p. And we're done. Thank you for watching. Subscribe, really helps out.